Welcome to the lesson summary video for the Math 1 task, Pooling It Together. This is a solidify understanding task, and the purpose of this task is to combine functions via addition, in this case, and solidify understanding of function notation in context. So Allie and Dane from the last task, who were draining their pools at the water park, have decided to team up and drain their pools together. So we have the equations from the last task. A of x equals 28,000 minus 1400x, and d of x equals 24,000 minus 1000x. And so from that we can create this new equation, g of x. And g of x is coming from adding those two equations. So by combining like terms, I can create the new equation. 28,000 plus 24,000 is 52,000. And then negative 1400x minus 1000x is negative 2400x. So by working together, they can drain the 52,000 total gallons at a rate of 2400 gallons per minute. And so we want to generate a graph of g of x on new axes. And so here I have a scale that's going to accommodate the size of this new graph. So you can see if Dane's pool had 24,000 and Allie's pool had 28,000, then together the total amount of gallons they needed to drain was 52,000. So the sums of the two y-intercepts for Allie and Dane separately add up to be the y-intercept for this new function representing both pools. And so by working together to drain both pools, we can see that the x-intercept, the amount of time that's going to take to drain it, is 21.6 repeating minutes, or 21 2/3 minutes. And we have this graph here that represents g of x in purple. So let me go ahead and make it clear this is g of x. So notice that while the two y-intercepts of Allie and Dane's functions, a of x and d of x, add up to equal the y-intercept of g of x, the x-intercepts don't add up to equal the new x-intercept of 21.667. So you can't always just add the points, because when we add points on a graph, we're adding the y-coordinates. So let me clear everything else out and give you another example. So you can see that the point 15, 7,000 is on Allie's graph, and the point 15, 9,000 is on Dane's graph. So 7,000 plus 9,000 is 16,000, which means the point 15, 16,000 should be on the new graph, which we can see it is right there. So to find any point on the new graph, we're just adding the y values from the two previous graphs and maintaining the same x value location. So now that we've got a graph for g of x, we can interpret some of the key features of the graph. So the domain is going from 0 to 21.6 repeating, or if we want to be super exact, that's 65/3, which is rounded here as 21.667. The range is from 0 to 52,000. So again, g of x is representing the combined gallons in both Allie and Dane's pools, and the draining of those gallons that occurs through both pumps working together. So again, this was time in minutes on the x-axis, and this was amount of gallons on the y-axis. We could also consider the maximum. So the maximum amount of gallons is 52,000. Obviously the minimum amount of gallons was 0. The rate of change, in this case it's sloped because it's a linear function, was negative 2400, and the units on that is gallons per minute. We've mentioned that the y-intercept was 0, 52,000, representing the amount of gallons we started with, and the x-intercept was 21.6 repeating, 0, representing how long it took to drain the pool. So those are the main things that we want to notice for this situation, and that's the end of this video. Thank you for watching. If you need help with the Ready, Set, Go's for this task, then please check out the Ready, Set, Go support videos in Canvas.